we'll get an update about what's going on with the Internet of Energy, IoE. As you know, you've probably heard a lot about this really abstract term that, is quite complicated to understand what it actually is, because it's quite a genetic term that refers to very many specific technology innovations that you have to really be aware of for the future. Many of these Internet of Energy innovations, if you like, you're still most likely not applying to your business, but you will have to with time in very precise areas in order for your company to become more efficient and therefore more competitive. This is part of a series. We've already done cybersecurity, we've done things on artificial intelligence, as you know, and also on data. And today we're discussing this Internet of Energy. With us today, we have two very big experts. You can only see one other person with me here at the top, but we actually have two people. You can ask him why he's hiding, but it might have something to do with cybersecurity in the Internet of Energy. And with me first, I'm going to ask Mir, please, could you introduce yourself and tell us a little bit about you?
Yeah, thank you very much. My name is Mir. I'm actually the IT director at Aqua Power International. And we are a company, we are into the generation of power and water desalination. We are across almost like more than 11 plus countries, having a portfolio of more than 23 plus plants. So today, hopefully I'll be discussing more into the Internet of Things and the Internet of Energy as an extraction.
Thank you very much, Mir. And you're joining us today from Saudi Arabia, correct?
Yeah, I'm joining from Saudi Arabia, Riyadh. Yes.
Thank you very much. As you know, I've already introduced myself. I'm joining also from Madrid, and we also have one other person with us, which is Francis.
Who's hiding away?
Yeah, he's hiding, but tell us a little bit about you and also where you're joining from.
Exactly. So good morning, good afternoon, everyone. My name is Francis D'Souza, and I'm the head of IoT services in Gemalto. I will share a little bit during the presentation about what Gemalto does, because 1 out of 2 chances you already use a product of Gemalto. I'm based in Paris normally, but I'm doing this call from Berlin because I'm here for an event. And one of the reasons why you just hear me speaking and you don't see me is because my company is a security company. And 2 years ago, the security IT director decided that, went through hacking attempts through webcams and cameras on laptops, and figured that the risk was too high, and there was some pretty sophisticated hacking attacks being taken out by that channel. So therefore, we had a complete replacement of our laptop fleet, and none of us have webcams on our computers anymore. So that's the reason you will just hear this voice.
We're glad not to see you.
Indeed.
But we understand. So you guys, so you know, I haven't had such security issues just yet, but you never know. So, okay, so today we have a little bit of a different structure from what you're used to. Today, because Mir is going to have to go after his speech, we're going to take questions for Mir right after he's done. So if you have any questions for Mir, please send them quickly, okay? Because he's going to take them and then he's going to disappear, but don't worry. We're going to have Francis still online, even though you can't see him, he's still going to be there. So he's going to answer any questions that you have. So Mir, can I ask you please to share your presentation with us, and so that you can get ready. And whilst Mir is getting ready, I'd like to welcome some of the people who've already said hi. There is Mark joining us from Beirut, and we've got Aditya from Hyderabad, and we've got someone also joining from San Sebastian, Spain. Please don't be shy, share it with us where you're joining from. I'm always amazed by how many different countries usually attend, how many people are represented, so it's always good to see. Yesterday we had also one for artificial intelligence, and we had people from Chile practically all the way to India, so it was really good to see. Okay, so just to let you know, we are recording this session. You will have access to the presentations, okay? Remember that Mir is going to have to go, so if you have any questions, please don't shy away and send them immediately. And Mir, we can see your presentation perfectly. Please go ahead. Just make sure you unmute your phone. Look at this, Morocco and Buenos Aires. Welcome, Gabriel Papa Rashid. Can you put that in okay, I see. Just unmute your microphone first, and then you can put it into a larger Oh, now, once you share your screen, you know everything moves, so it's really hard to. It's much harder to do it. Oh, and welcome Ira from Freiburg as well. There you go. You just have to put it in large screen, and you're ready to go.
I hope everybody is able to see it.
Yes, it's perfect now. We can see it.
All right.
Go for it.
Let's start. All right. First of all, thank you very much to everyone for making this particular session. Now, the objective of today's session is to basically tell you about Internet of Energy, but I'll start from the Internet of Things to give you an overview. And before I start, I just wanted to also tell you that most of the extracts that I will be showing it to you, they are related to GE work, and we at Aqua Power, as I've introduced earlier, are already under the implementation of a platform from GE called GE Predicts. So it's basically about GE Predictive Analytics as well. So let me just take you through this whole presentation very quickly. What is basically the future that is going on is back in 1995, between 1995 till 2000, we were always working on the back office automation. So that area was covered in that era. And then later on, it moved into the social media and CRM, which is Web 2.0, where everybody can understand that it has been transformed of connecting people and more into data-driven and analysis accordingly. Then the things are now moving very, very fast on the industrial internet, which is basically the machine-to-machine learning. So now it's not only just systems, it's basically the data that has been collected across different machines. They are basically talking to each other and giving us the information and helping us in taking decisions. So IoT has derived a lot of things like IIOT, which is Industrial Internet of Things, which there is Internet of Energy as well, the IoE part, and people normally also call IoE as Internet of Everything, and mostly they say Internet of Important Things as well. So what is it all about? I'll give you a very real-time example, and I think this is something that you guys have to all look into it. I've shared a link as well. Maybe if people can open this link, they can also understand what we are saying. See, there is a new concept that has been now introduced in the market, which is basically a digital twin concept. So what's a digital twin? A digital twin is basically a device. It's a model, it's a hybrid model in which a machine works as if it has some mind into it. What do I mean with it? Take an example of a power plant. If you have a power plant, you don't have a test instance for that particular power plant. You have a production instance directly. And the major issues comes out of this only thing that we don't have a test environment. If people most of the people joining here might have been from an information technology background. So whenever you do any kind of an ERP implementation, you always know that there is a production instance, there is a test instance, and there is a development instance. So whenever there are any issues, you go in your test environment, you test it out, and you then come out with results. But this cannot happen in a multi-million-dollar industry. So what they do is, you have this real-time, I've shown in the second picture, a real-time device, which is a jet engine, and then they have sensors. These sensors basically give the information on a real-time basis to a working, living model. That's very important. And that particular digital model, it works as if it is working like a machine itself. So it takes all of that information, and when it takes this information, it starts behaving over the number of years exactly how the engine is working. So that's a living model. And when I mean that now, after that, with this digital twin, what you can do is you become more proactive instead of being very reactive. So you have a complete predictive analytics working into it. So there is a video that I have shared. Maybe when the presentation will be shared with all of you, you will see this particular video. In this video, you will see how GE has worked out to create a digital twin for one of the power plants itself, and then how this is working for predictive analytics perspective. Let me take that idea further from an IoT perspective. Basically, what happens is that this living model has three things in tandem. There is a C effect, which basically takes all the data, as I said, from the real device. It models it out and it starts giving you solutions. And on top of it, then it gives you the learning capabilities as well. It has learning, and then it does thinking and optimization. So when it goes on to an IoT cloud, what happens is that similar machines over 15 years of data, or more than let's say more than 100 plus similar machines, it collects that information and then gives you the analysis if a certain issue has occurred. And predictively, it tells you how are the actions that you need to perform to fix that out. And then later on, when it gives you options on selections, it also then gives you the control that you can select that option and it will apply that particular option both in the digital twin and in the real-time environment as well. So that's has the digital twin concepts works out. So basically what I'm trying to make here is that the IoT platform has now been transformed into this particular research area which people are working on called digital twin. And from an energy perspective, when it comes to generation, power plants and all, they are basically moving in this area. And they are investing in this area so that they can have a twin environment of their same power plant. And at any given point in time, they can find out, they can handle predictive analytics, they can handle any kind of, let's say, for example, issues proactively. So the outages, the unplanned outages, you know, almost millions are being paid on unplanned outages when it comes to power plants. So if, for example, you can save that money during the using this technique, you will really feel the value out of it. So it's basically this area that is the recent area that people are working towards it. I've also given an example, a digital twin for a transformer. It gives you the full information of how the transformer can behave when it is in a digital twin area, and you can set your KPIs and you can set what are those failure modes and effects, and you can see that if a certain issue comes, then the lifespan will be decreased. So how can you increase the lifespan of a transformer on a certain plant that can help you out? So you have the full analysis and you start then replicating it out. When you start replicating that particular twin out, you will have a new horizon altogether in which you can cover different aspects and different areas. It all breeds out from Internet of Energy, you can say, or Internet of Things. Similar kind of research is going on these days for everyone to note, because I saw some of the university students also joining. So this is a very good research area going on these days for the human digital twin as well. So there are devices, IoT devices, sensors, they can be fixed onto specific areas within the human body, and it can give you all the information, a real-time data information. And this is basically advancing a lot in the medical healthcare research industry. Now, what are the constructors for the IoT itself? So people should understand here. So basically, if you see the diagram itself, there is something called producers of data, then there is the platform itself, and then there are consumers of data. So IoT constructors are basically those components that divide the complete IoT platform. So operational and environmental data is being gathered from different sensors or different producers of data. So wherever data is getting produced, these particular information is being grabbed into and then it passes through the multi-service gateway. So there are different gateways. These particular gateways, it takes the information and puts it into an integration platform. The machine-to-machine integration platform, it takes the machine data, combines it, does the analytics, and after it does the analytics, it will take and give it to the consumers to the way they want. And then the systems will get interconnected. So always remember, IoT constructors are basically around these areas, these core areas. You will always find environmental data sensors that will give you the data and inputs the data back through the gateways. Maybe sometimes they are directly connected to the M2M platforms. And then the M2M platforms will have the complete integration done, and analytics will happen there, and then the output is being produced and sent to the consumers. So keep this in your mind. I'll elaborate more further. The complete cycle is also mentioned here. So as I mentioned here, you can see acquiring the information through sensors, controls, meters, transactions. This will happen. Then once the data is captured, it is basically being organized. And when the data is organized and all the semantics are being done, then it is being stored somewhere. And when it is stored, then the whole analysis happens, which will give you features like predictive analytics, which will give you optimization. You can do your optimization, you can do your mitigations, and then you can do your forecast. If you step down into the power industry or the power plant industry, you will literally realize that all these aspects are like of $1 million to any financial person. So if, for example, any risk mitigations have to be done or any optimization needs to be done, we are talking about millions of dollars here. So when it comes automatically from the system, you can always get that information from these IoT cloud environments or the IoE environments, and then you can take your decisions properly. Now, what is the concept behind this IoT model is basically creating a hybrid model. What is a hybrid model? It's a physical model which gives inputs real times to a digital capable environment. And then there is machine learning on it. So it keeps learning over the period of time with the artificial intelligence embedded in it, along with software analytics to create this out. So in this diagram, I've tried to explain you that let's say there is a physical object. Against that physical object, a virtual object is also created. And that particular virtual object basically gives you the full information of how that physical object is working over the life period. So let's say if today my power plant comes into operation, today the data that is there in the power plant would be 1 day old. It's the same object that is created as a digital twin, it will have 1 day old data. But at the moment it starts working for 10 years, 15 years, the data inputs are going into that virtual model, and it also starts behaving exactly like your physical data. Not only this, always remember, when this comes into digitalization, it can be always expanded. So it's not that the power plant of Aqua Power has been into this world for 1 day. No, there are other power plants. So when that data gets combined, it gives all that experience to help new industries or new power plants to solve their problems based on these analysis. So just keep this in your mind that the moment a physical device turns into a digital device, the same digital device, then there is what we call elasticity coming in. And that elasticity will give you all the strengths that IT can come up or IoT can come up with. Now, exactly like the same thing, I've tried to give you an idea into another video that is from an IoE connectivity perspective. This is a very fantastic video. There is a blockchain company called Grid Plus. This Grid Plus, what they have done is that they have created a small grid within the main smart grid. So they will give you a small device. You can see in the video, they can give you a small device, which is called Grid Plus. You can take it at home and you can connect it. It's an IoT device. Now, what it also gives you that you can have, it tells you you can have different panels, solar panels. So whenever there is, let's say, the solar energy, it creates it transforms it into the electrical energy and it stores in the battery. And then this particular device, what it happens is, it gives you a trading platform. So the concepts like demand response, the concepts like demand response, the concepts like dynamic pricing, all of these can get covered with these particular devices. So what happens is that when there is, let's take an example. When there is sunlight energy, it takes it through these panels and then starts converting it into electrical energy, which will supply your home, residential home requirements. And then it also stores excessive energy within batteries. And what happens is, this energy that is stored with you, you can trade it. So peak hour tradings can happen. So for example, if you're selling up a kilowatt of energy for 1 cent in a different peak hour in different world, you can sell it out using that same grid in let's say, for example, 2.5 cents or more than that. So you start making money as well. So this IoT has transformed the concept completely of even energy utilization within residential homes. Plus, not only that, plus also selling it back, because you yourself will become like a kind of a creator. All right. So please do see this video and you will be finding it very interesting. The same concept is basically, I've tried to explain here, is the building energy efficiency management, where dynamic pricing can happen, demand response can happen, electrical vehicles charging can happen as well. So when electricity starts producing inside your own vicinity, you can use it and you can give it, outsource it for electrical vehicles to be charged. And then you can work on into optimization as well. The electricity business, the IoE, has also been transformed into complete cloud-based and web-based building efficiency management systems as well. So what had happened is that when you have your own house, you can do your quality efficient response to those particular homes. You can control that. You can make sure that since there are IoT devices and sensors, you can control all your home devices. And by the way, there is a research going on these days within Philips. If you guys can also research on, find out that there are IP-based devices. So there would be like air conditioners with having IP addresses. So there would be bulbs that would have IP addresses. So what will happen is that, like in an internet based environment, when IP is given and an actual address is available, then it connects to the network. And when this means digitalization can be possible. So what I'm trying to express here is that with this advent of IoE in the world, things are moving towards complete digitalization. And then what will happen is that all of this will get interconnected. And when these things will get interconnected, if you see my first slide, I said things are being transformed now from IT to OT environment. There's a conversion going on. So it's no more systems and data. It's about devices talking to each other. So imagine all the devices that you have in your offices, all your devices that you have in your homes. When they start get connected to each other, there would be a lot of information sharing that will go on, and a lot of digitalized efficiencies will come out. So that's what I've given as a hint here, that quality and efficient response can happen. Intelligent based approach can be handled here as well, and manageability becomes easier. So now see this small concept, people connecting here from Spain. Francis, my friend, is connected from Berlin. Before like 30 years before, this was not possible even. We had to spend a huge amount of money on the travel tickets to have these kinds of, but now everything is online. Why? Because of digitalization, things got connected. So the same way, people will be able to have this whole thing through the Internet of Energy. One last slide before I end and I start taking questions. I hope I'm not seeing the chat window as well. Maybe there would be questions there, but I would like to also specify that within power plant industry, we are handling cyber security as well, because people will always come and question this thing. Security, I always say to people that these are not disablers. Security is an enabler. So we always have to take security as an enabler. It's not a disabler. So there is a device called data diode, and data diode is a device, if people can research on it, most of the people might know it as well. This technology we are using in power plants as well, is that it creates an environment of unidirectional traffic. So there are firewalls, but firewalls by blood are bidirectional. Data diode by blood or by physical thing there is a single connectivity that goes in one direction. So this is my network, which I'm showing in my source network, and I've installed it, by the way, in my power plants as well. So what we do is we have our secured environment, and then it pushes data out. When it pushes data out, then the threats and everything gets mitigated, because there is no duplex channel onto it that any kind of an intruder can come inside the organization. So it just pushes the information out. So it's one-way traffic, and it does that. Now, there are multiple questions and scenarios around when I was implementing GE, when I'm implementing GE with GE Predicts right now. I had made the same model with them. So just to end up and give you a real-time example, GE, these kinds of environments which are based on IoT clouds, they need bidirectional, by default, they need bidirectional connections. So what we do is you use something called replication strategy. Now, these are some business traits that I'm sharing it with you, but this is good if people can do some research as well. That what happens is that you can have a server behind the data diode that will take all the information from all your SCADAs and historians and put it there. And then it pushes overnight, or let's say, for example, or let's say synchronously, it pushes the data out onto another server. So when it passes through the data diode, it is going in one direction. But when anybody from an IoT cloud will connect, he will connect to the external replica. He doesn't care whether he's going to the internal replica or the external replica, because he needs the data. So when we push a unidirectional data from an internal replica to an external replica, it goes in one direction. But when it goes out to the cloud, it goes in bidirectional way, that it talks to the external replica, and that's complete bidirectional. So they don't care whether the IoT data is coming out directly from within the plant quadrant or it is coming out over and above the data diode. So just go and research this field as well. This is called the data diode. It is a very important device that you can always use in your networks to handle cyber security as well. So I am done. Thank you very much for the time as well, and I've tried giving you the explanation of how things can help you out.
Thank you very much, Mir. I know that you have to go. We do have a couple of questions, but just to let you know, that second video that you sent the link, that one is not working. So we'll just send it to you in an email, see if you can tell us what the right link is, because I think it's very interesting, and we'll make sure that everybody actually receives that. So there are a couple of questions here. Thank you very much, Rashid, for sending them through. One says, how, in your point of view, how will IoT impact power generation sector, and how will developers like Aqua benefit from this?
Yeah. Rashid, the most important thing here is that from a generations perspective, there is something, as I explained, the digital twin. The IoT, if IoT is there, then you can take that information from the real power plant and then give that information using the IoT sensors and devices to your digital twin. And that digital twin will behave like a testing environment, a live, living testing model of your power plant. And when that happens, then all your generation problems, power generation problems that can come on real-time basis within the power plant can be replicated into a digital twin. And when it is replicated into a digital twin, you can solve your problems much easier. You don't need to bring or do a shutdown of the real plant. You need to work onto your digital model and find workarounds on how things will happen. So I think the first video that I shared, I will try to share the second one as well, as mentioned, that it's not the right link, but I will share it. So if you see the first video, you will realize what I am talking about.
I have to say, Amir, I really dig your passion for this topic. It's really infectious. So I really like how you really clearly like it. Okay, 2 more questions. I know you have to go, and also Francis is waiting to speak. So similarly to GE, is there any digital transformation plan for Aqua Power, and is IoT one of the priorities?
If I understand your question correctly, you're saying that is there any other IoT projects around except the digital twin?
So it's just saying, do you have any digital transformation plan for Aqua, and how high does IoT rank on that plan?
There are a lot of digital transformation areas that we are working on, for sure. IoT is one of that particular thing. There is another digital transformation, if you want to hear. This is called robotic process automation. It's called RPA. RPA is one area that we are constantly working on. It basically works into a digital area which calls repetitive and structured automation. So let's say, for example, if there is an accounting team that is sitting here and they are doing the same thing all over again the whole month. So instead of that team doing it, why don't we ask a bot to do that? So that's an area of digital transformation called RPA. If people want to listen to it or they want to see it, they can go and search it. This is another area that we are working on. And there are several areas, of course, that we are exploring.
Okay, one last question before you go. How much would an IoE solution for a project would cost in terms of a percentage of the total investment? I know it's a very tricky question, but perhaps we could say, it's very tricky because you could, there is like a million of answers, but what would you consider a good investment, in terms of cost opportunity for IoE into a project today? Yeah,
see the project that we are doing for plant monitoring and analytics one, it's extremely expensive. The only thing that is making a business sense, since this concept is new in the world, and a lot of big companies like GE, Siemens, a lot of big companies are trying to invest, because all of this, it's dependent on one thing, Billy. It's dependent on the data. So the real data that it has, they already have simulators. They just need to give the real data. So what we as power plants comes in is we provide them the real data from the historian environment for 15 years, 10 years, 20 years, 40 years. That's the value for them. So it's a trade-off between those companies and ourselves, that we come on to a conclusion to make it a very cost-effective one. Otherwise, if people want, because we are, at the end, they need data and we need the technology. So it's like a merger of it. So it's kind of a compromise that has happened in which we had made it as a business sense within Aqua Power. And I would recommend if anybody else from any power industry is listening to this webinar, he can also use the same trick. But if you try to work on this solution, create on your own or buy it, I think it's an expensive proposition for sure.
Thank you very much, Mir. Well, thank you very much for everything. We've detained you long enough, so I hope that it goes okay in your next meeting. And without further ado, I'm going to ask also Francis to share his screen and start his presentation, because it's nearly now 37 past. So thank you, Mir, and see you next time. Right, Francis,
Great.
you're really quick.
Can you guys see my screen? Full.
Perfect. So, thank you very much. You're ready to go.
Great. So guys, I'm Francis D'Souza, and I work for a company called Gemalto. I look after the business called IoT Services. And like I promised, I said Gemalto, you're probably using Gemalto already. So Gemalto is a company. We're headquartered, we're very global. So we have we're listed on the stock market, and we have a 3 billion euro turnover, and we do lots of things. So if you use a SIM card, as most of us do, 1 out of 2 chances it's a Gemalto SIM card around the world. In addition to that, what we also provide is protect. So when you have a SIM card, it actually protects your phone and the operator network from security hacks, etc. In addition to that, if you're going through, very often through immigration and passport control, especially if you go through the US, you're going to see all those readers that you go through for your biometrics that comes from Gemalto. The data, when it's stored at companies and they want to prevent data hacks, so even if someone hacks into the network, the data is encrypted. There's technology that's provided by Gemalto. And coming more to the IoT side of things, so you see that car out there. So if you have the good fortune to drive an Audi, the Audi is connected, and that's connected with Gemalto technology. So it's connected to the cellular network, so your car acts like a phone. So that's the kind of stuff that Gemalto does. But the underlying element of everything out there, that what we bring to the table, is secure connectivity. Okay, so what we do, and our customers are large telcos like Telefonica, Orange, Vodafone, AT&T, STC, all of them. Banks, so Santander, BNP Paribas, all of the banks are customers, car companies, etc. So we don't have products directly for end consumers, but we have products that help our customers offer digital services that can be trusted to their customers. Okay, so that's typically how we do. And I mentioned the banks because the payment cards that are used for payment, either physical payment with chip and PIN or contactless payment cards, are also made by Gemalto. And with that thing of what Gemalto does, I'm now going to go delve deeper into what we do in the Internet of Things with relation to smart energy, because one of the things that's actually happening is that electricity utilities, especially on distribution, are becoming massive IoT networks with all smart metering and everything that's connected. And one of the, let's say, acronym I'm going to use is Distribution System Operator, or DSO. So that's essentially, it means your electricity supplier in the field. Unlike power generation, because Mir just spoke about, he spoke about the power generation part, and then you've got the supply part. So initially, utilities started to connect their meters and make them smart meters was to reduce OPEX. Okay, so they don't send someone to take a meter reading and on-field intervention, they do it remotely. It started out doing that. However, and this makes an absolute link with what Mitch just spoke about earlier, they're also doing it to get real-time consumption data, okay? Because now what also happens is they might buy power in real time. So I was speaking to a utility in New Zealand a couple of weeks ago, and they buy power in real time wholesale, but they need to, their traders need to know how much power to buy, which is why they absolutely rely on their smart meters to know the consumption, etc., in real time and the trends. But also what's actually happening is consumers are also becoming producers. So if you remember one of Mir's slides where he showed a box where, you know, you have a solar panel, so you get power from the grid, but you also feed back into the grid. You need to have smart meters, you need to have things connected. But when you look at all of this, what it means is that the data that's coming from the meters is extremely valuable. But also it means that the data needs to be absolutely trusted by the backend system, by the utility. And what, in the absence of, I'll just go back. In the absence of being able to trust the data or being able to protect the assets in smart metering, there's lots of potential hacks or, potential hacks or potential, let's say, sabotages that could happen. And essentially, what I'm going to be speaking from now on is about what these potential threats could be and how they could be protected against. So first, it's important to know the actual architecture of the infrastructure. Typically, the way it is in the backend system of the utility, you have this acronym called HES, which stands for Head-End System. And the MDM is Meter Data Management. This is the backend, okay? In the homes, you have all of the smart meters. The smart meters are connected to the head-end system, sometimes directly over cellular connections, or very often through an in-between gateway or a data concentrator. So the smart meter is connected to a data concentrator. So multiple smart meters are connected to a data concentrator that uses technologies like power line communication, PLC, or mesh. And then a data concentrator is connected over cellular. Okay. But when you have this, you look at the attack surface, the number of areas in which a hacker can probably attack. And what I'm going to speak about is three kinds of actual things that have happened in smart metering deployment and how they could be protected against. The first is tampering with meter data. So these were smart meters that had their credentials very poorly stored. And in fact, they just use passwords. And in security, I mean, using passwords, especially for IoT, is a complete no. One should use keys and certificates. So those are the kind of security techniques to be used. And what happened was former employees stole the admin password and made it available to a lot of people. And then people will kept altering the meters to change their bill at the end of the month. And the utilities revenue massively declined. So this was an attack on the smart meter itself. A second one, and this is something that Belen, I was telling you about slide 6. This is exactly what we were talking about your fridge earlier. So what actually happened was hackers connected into the data concentrator. So now you don't connect to one meter, but essentially when you go into a data concentrator, you get access to multiple meters. And the hackers could figure out, because nothing was protected, about which homes were empty or not. And therefore, they were planning extremely efficient burglaries because they could see from the consumption who was at home, who was not, and a very efficient way of doing stuff. And the way of protecting this was very simple. Encrypt the data, and even if someone breaks into the system, the data is encrypted. They don't have they can't do much with it. And the third one, which is probably the biggest in terms of impact, massive impact, is probably the most dangerous and typically carried out by state actors, is to damage the entire grid itself. So what actually happens in this, from the back-end system, from the head-end system, hackers took control of the head-end system and sent commands to 50% of the meters in a city to turn off. The other 50% in the other side of the city to surge power from them, to pull power, draw more power. So it completely destabilized what the grid was built for, because when you plan distribution, you plan for certain load, etc. And then we got control of a grid and we distribution. And this could be done, protected in a very simple way, which is ensuring that the communication between the meters and the back end is set up in a way that's trusted. So meters do not just receive commands from any system, they receive commands that are authenticated and trusted, so that even if someone hacks into the back end, they can't do much with that hack. So these are three examples to show how on the attack surface you could have an attack on the meter, you could have an attack on the gateway, or you could have an attack on the back end. So if you were to put that together, there's three reasons for these utilities to mandate security. First is fraud prevention for themselves, for their own bottom line. The second is privacy protection of the consumer, and then massive availability of the system itself. And if you were to paraphrase it on security, because security can tend to go in all directions, what we would put it as four principles. First, one needs to trust the source sending the data. And one of the ways doing that is by putting keys and certificates into devices. Diversified means every device has its own unique key and well protected. The second is ensuring the data is shared between trusted entities. So that's the word called mutual authentication. So the device trusts the backend trusts the device. And there's a technology called PKI, public key infrastructure, that's typically used and is used quite a bit in IoT and especially in smart energy. The third one is encrypting the data to ensure that even if someone hacks in, they can't get much. And the fourth one, which is very important for the Internet of Energy, where you've got long life assets, is to ensure security updatability, because no one can ever guarantee that something cannot be hacked, because the hacking techniques get more sophisticated. But if there's a way to ensure that things are upgradable, it's fine. You can protect it even in the future. And especially on smart energy, there's a lot of focus and attention coming from regulation. So you've got, in the US, you have NIST, which is the standards body that is still advisory, asking for all these keys to be implemented on smart meters and to be changed every 1 to 5 years. In the EU, you already have the GDPR, which deals with data protection, and that leads to needing to encrypt data. But there's more stringent regulation coming next year called the EU Cybersecurity Act. And one of the areas is on utilities and critical infrastructure, where there's going to be a lot of mandatory requirements on implementing security on things like smart metering. So what we have as Gemalto, we've got what we call a trusted key manager that manages all of these keys. I keep repeating about keys and certificate, and it's very hard to be able to generate keys and distribute them across millions of devices. So what we do is we've taken that complexity and built it into a product called a trusted key manager. And in fact, this is the same slide as the first one, but just in the other way around. You've got your smart meter on the right, the data concentrator, and the head-end system. And to the head-end system, connected over an API, we have the trusted key manager, which in fact acts as a security layer for the head-end system and the smart meters. And the trusted key manager has internally an HSM. This is like a storage vault for your keys. It manages all of the device identities and the public key infrastructure, the PKI that I mentioned, very specific to the smart grid, because it has characteristics very different from, if some of you from an IT background, you might say, yes, we use PKI and for our office email system, etc., which is true. But when applied to IoT, it's quite, it has very certain specificities, because the devices are not as powerful as, let's say, office PCs, etc. So that's why it's called a smart grid PKI. And there is a specific protocol used in the energy industry on distribution called DLMS. So it's used for electricity, gas, and now even water metering. So what the TKM does is all of the commands that are sent through the head-end system to the meters, all of that is done within the DLMS protocol. So it's a complete key management system, but really adapted to the smart grid. And what kind of use cases does it enable? What it enables is initially secure generation of keys to be injected into the meters and the data concentrators. And during the life cycle of the meter itself, The first time a meter comes online, a utility often chooses to change the key. So it does it automatically. So because the utility might still not trust the manufacturing facility where it was produced. So therefore, first time a meter is connected, it connects to the head-end system, the utility changes the key. Once that key is changed, all of the data exchange between the smart meters and the backend is encrypted. What is also done is to ensure that devices can be securely updated during their life cycle. And then, of course, supposing you've got to change your keys every 3 years or 5 years across millions of meters, it's just a press of a button, because all the management of those key changes and the flows is business logic of the trusted key manager. And this is the same slide as earlier, but just on a timeline. So if you look at it, the TKM gets called into action right from the production of a smart meter to a complete device deactivation or reallocation 15 years down the line. And again, why is all of this being done? This is all being done to ensure that the data that is being generated by these smart meters, whether it's a smart meter just for the consumer or whether it's a smart meter that's also connected to a solar panel to generate renewable energy, the data can be trusted by the utility. Okay. So this award, this product also got an award in the category of smart cities, governments, and utilities by IoT Now in March this year, and that's a PR also with our on the trust key managers. So this is something important because of the regulatory attention in the area as well, and it's complex for people to build and for utilities to build. So we've already created this trusted key manager out of the box. And generally, Gemalto is quite a lot in the metering business. So we have the wireless modules that connect a meter to the back end, then the trusted key manager that secures that connection, and a lot of other stuff as well. And if we had to just give you a takeaway on the trusted key manager that's used for smart energy, it's very comprehensive and tailor-made for smart metering. So I mentioned about the DLMS, sorry, this is a typo, it's DLMS support and the PKI for smart metering. So it's really a key management system for smart metering. It's ready to use against a utility having to build it from scratch. And it's future-proof. So it allows things like updates to be done 5, 10, 15 years down the line, so that even if there are new hacking attacks, etc., firmware can be securely updated over the air. And that's my brief overview of the Trusted Key Manager.
Thank you very much, Francis.
Pleasure.
So we have a question here, and I also have a couple of my own. I don't know, we don't have a lot of time because we need to I think we've went over quite a lot with the last presentation, but there's a question here. And it says, with the new data safety regulations that are being implemented in Europe and other parts of the world, is it likely that future installations and systems will have to be built for data safety and trust? However, how is it possible to find out these attacks before they occur, such as the one you mentioned before?
No, that's a good point. So in fact, there's a concept in security called security by design. So it's important for these systems to be built in such a way to be able to prevent these attacks. Okay, so and these are security principles that have been the same for the past 20 years. So if, for example, we take in the principles of ensuring keys, ensuring that things are properly protected right when designing a solution, the attack won't happen. Now, it could also be that there are attacks that come later, in which case we need to have the updatability of systems to be able to download dates or whatever to be able to prevent future attacks. But one of the things, and that's a key word, security by design. At the design stage of your system itself, you need to take these questions into account.
And I'd like to ask another question, and that will be it because we really need to go now. But in terms of this last point that was made here in this question, how can you, by using standard, softwares or whatever you want to call them, because I don't know what they would be called, by using standard products or softwares or solutions, it seems to me that the attackability of these things is more rather than less. Whilst when you build your own, you know that they're all very specific. So a hacker can essentially go after Gemalto and then all of the,
sure.
You know, so how does that help, not help, you know, it's just wondering.
Okay. Understood. So your question is, because I mentioned things are built on PKI and open standards, and why does it make it more secure? Because it's open and many people have access to it. That's your point, right? Okay.
Yes, that's my point. It's like,
okay. So no, it's a very good point. It's a very good point. So in fact, in all of the PKI and the security algorithms, these have all been they're mathematically tested and cryptographically proved. Okay, by it's done by I mean, it's all these mathematical algorithms that are used now were done in the early 90s. And they've been, and the important thing about security is the more open it is, the more you have more people, either in industry or academia, that are trying to hack it and test it, and only then does it get implemented in a market. On the other hand, where you build private systems, because only a certain company might build it, if it gets hacked, it's compromised. Whereas in the case of open standards, you've got thousands of academics and researchers going after it. And basically the current security standards like PKI, these will last till quantum computing. Then when quantum computing comes, there will need to be a different way of security implementations.
Yeah, I can't wait. I think quantum computing is something that needs to be approached as well, you know, in one of these webinars. Thank you very much, Francis, for joining us today. There is a couple more questions in the chat, but we don't have time now. So I'd just like to thank you very much for your time and for sharing with us. And also thank you very much for all the people who join us from the audience. See you next time. And of course, you will receive the presentations and the video. Thank you very much. See you next time.
Thank you all.
Bye.